Alright, so with these recurrence relationships, just have to be a little bit careful. So let's have a look. So B1 is true, or sorry, P of 1, let's let the proposition P of n be represented by P of n. Let's look at P of 1. So really we're looking at the first thing, so n is, in this case is equal to 1, and we're checking it out. So for B of 1, let's see, I'm going to assume it's true, even though I shouldn't. So it's true since, okay, it is true since when I put it in the recurrence relationship, so into the bit that is defined by the sequence, B1 is 4 plus B1 minus 1, so big 0, which is 4 plus what is B0? B0 is 5. Alright, and if I do it just using the equation here that we have to prove, B1 is 5 plus 4 lots of 1s, which also equals 9. So far it's true. It's all set up really nicely. So it's true. Our assumption then would be that our P of k. So if P of k is true for some arbitrary integer k is greater or equal to 1, then B of k is what we'll be looking at. And this is what we're trying to prove. So B of k is 5 plus 4k. Alright, so what are we required to prove? We're required to prove our k plus 1, P of k plus 1. So that would be that B of k plus 1 is equal to 5 plus 4 lots of k plus 1s. That's what we're trying to prove. Alright, so let's look at, have a look at our left-hand side. So our left-hand side in this case, which is B k plus 1. Now, remember, we want to use this, the P of k. So in order to do that, we want to use bk. And so in order to do that, we're going to have a look at our sequence, because that brings the B of k into the B of k plus 1. So our B of k plus 1 is just 4 plus B of k plus 1 minus 1, which is B of k. Sorry, that's 4 plus B of k. And now we can use this bit from P of k, which gives us 5 plus, if we take the 5 separately, and if we factorise the 4 terms with 4 factors of 4 in them, we get that, which is what we wanted, which is our right hand side. So I really should maybe write here that I'm using the recursive formula. Alright, so the bit with the sequence, recursive formula, that's where I'm getting that from in order to use the bk. Alright, so therefore P of k implies P of k plus 1, therefore P of n is true for integer n is greater or equal to 1, and we've done it by induction.